Precalculus. Okay. Tests handed to you. To you, to you. Where are the rest of them? What has happened? What is happening right now? What is even going on with my life? Oh. Oh, look, I'm supposed to give these back to you a long time ago. I mean, like 2 days ago, anyway. Why is the only one sitting here Malcolm's? Didn't I grade y'all's test? Or did I not grade it yet? Maybe I didn't actually finish grading it yet. I thought I did. Where's everybody else's? Oh, there they are. Why did I grade you two and not Malcolm? Well, y'all will all have to wait then. Sad day. Okay, 5-1 is where we starting.
He's gonna start like tweeting or something. Need my test score.
All right, we're going to learn some identities. We're going to learn a crap ton of identities throughout the course of this chapter. This chapter is mostly identities. That is mostly what you're going to learn.
It's a matrix.
You can think of identities kind of like postulates. Well, that's good because that's the next chapter.
Yay! I was like, what's a postulate?
Yeah, so that's kind of what they are, where this thing equals that thing. And then we're going to use the things to turn out one thing into something else. Yippee skippy. So, the first set of identities you actually already know, and that is the reciprocal identities. Reciprocal identities are these: that the sine of theta equals 1 over the cosecant of theta. The cosine of theta equals 1 over the secant of theta. The tangent of theta equals 1 over the cotangent of theta. You also know the rest of them. That the cosecant of theta equals 1 over the sine of theta. The secant of theta equals 1 over the cosine of theta. And the cotangent equals 1 over the tangent of theta. You also know what are technically called the quotient identities, but it's in the same grouping, and that is that the tangent of theta equals the sine of theta over the cosine of theta, and that the cotangent of theta equals the cosine of theta over the sine of theta. Right? All of those you know, easy money. Okay? So we won't even worry about examples with those. Those are easy. The next set of identities, which you will use a lot. These are ones that are used all the time in these problems. And that is the Pythagorean identities. The Pythagorean identities are, like their name suggests, derived from the Pythagorean theorem. Easy peasy. That is the Pythagorean theorem. That's true. The first Pythagorean identity is that the sine squared theta plus the cosine squared theta equals 1. Two things. One, we're not going to do the derivation of these for the sake of time. We're not going to walk through how these identities are built. All right? We'll leave that to other people. Number two thing, we've talked about this before, but to remind you again that this means this. Those are the same thing. What?
Kind of a little bit off topic, but are we going to be doing like derivatives and stuff?
No.
No?
No.
Oh.
That's calculus.
Why are you not like this unit, but like
Sometimes I
this
just
here?
want to smack this guy.
Unlikely that we'll get that far, but it's possible. Barely, if at all. It's not likely though. Also, a second reminder in relation to this, that this, we've been over this before too, does not mean this. Right? So you have to know which one's which, each by context. So this does not mean sine to the negative 1. I know, it's annoying, but context, clues. Right? So there are two more Pythagorean identities. I like to remember this one as secant singular. Let's see why once we write it. Tangent squared theta plus 1 equals the secant squared theta. So secant is by itself. Tangent gets added 1, right? And if that's true, now these are ways that you want to start thinking. You want to be able to start kind of thinking about twisting these up in your brain, because then you'll be able to see patterns later easier. Like, if this is true, then cosine squared theta equals 1 minus sine squared theta, right? And sine squared theta, or I said it backwards, right? This 1 equals secant squared plus minus tangent squared, right? You want to be able to think about those in those kind of ways, because that's what we're going to be doing. We're going to be seeing patterns, and we're going to be changing stuff, right? And then the final one has cosecant by itself. Cotangent squared theta plus 1 equals the cosecant squared theta. And those are the Pythagorean identities. Let's do an example that would need Pythagorean identities. We're going to find the value of each expression given the given information. We are given that we want to find the cosecant of theta and the tangent of theta. And we are given that the cotangent of theta equals -3. And cosine of theta is less than 0. Right? So let's see if we can use all of the kind of bits of information that we've had in the past to get where we're getting. In the past and present, potentially, right? It does say cosine. We can find tangent easy. That's true. Tangent is -1/3. True enough. because it's the reciprocal of that one. Now, to get from cotangent to cosecant, we can use the Pythagorean identity. So which Pythagorean identity are we interested in?
Cotangent squared plus 1 equals so cosecant is square root of 2.
There's something you're forgetting that we need to make sure we do correctly, right? 3 squared is what? 9. 9 plus 1 is 10. Cosecant squared theta.
Plus or minus.
Take the square root of both sides, and we end up with cosecant of theta equals plus or minus the square root of 10. Now, we need to know which one it is.
Cosine is less.
Cosine is negative, which means we're in which 2 possible quadrants?
Left 2.
So it's either here or here. Okay? Cotangent is negative 3, right? So
It's in the top left.
means it's up here somewhere, right? So is cosecant positive or negative up here?
Positive.
Positive. Because sine is positive up there, right? Last one. Better order some more before I forget. You can't say that. We haven't been saying that since like the 60s, bro.
What?
Colored.
It's got to be a quote from a movie.
No, it's not a quote from a movie. I was making a joke.
That's what's always.
I was comically saying that you were being racist. You weren't, but that's what I was saying.
What did you say? I called markers colored.
He did call markers colored.
Those markers are colored.
Colored markers.
They're,
They each have their own place.
they're not binary colored markers.
Dang.
Buy it again.
That's crazy work.
Add to cart.
Get back to. That is not what I expected to hear from Alvin right there.
Each have their own place. Wow. Crazy work. Every once in a while, I come up with a good one.
Camden said we shouldn't expect those grades back on our history stuff until like a month.
I emailed the professor and asked him about the John Bell one. And
What did he say?
Bam.
He said he'd give everyone credit.
Okay.
Yeah.
About 8,000 trophies.
Good
I
stuff.
just got to.
All right.
I'm at 7,900.
I'm higher than y'all.
The next set of identities build on something that we observed in the last chapter. So in the last chapter, when we started graphing sines and cosines, we discovered that sine is just cosine phase shifted, and cosine is just sine phase shifted, right? And so that's where these identities come from. These are called the cofunction identities. These are called the cofunction identities.
These are easy to remember. Thanks. Wow. I've already got that one.
You gotta remember us.
I do.
He's got it. Okay? And they go like this. The sine of theta equals the cosine
Oh, that is easy.
of pi over 2 minus theta. The cosine of theta equals the sine of pi over 2 minus theta. The tangent of theta is pi over, excuse me, it's the cotangent of pi over 2 minus theta.
Nice.
All of the reciprocals are the same. If you want to include them, you can include them.
Yay.
They're all the same as the others. The next set of identities is called the odd-even identities. And the way I rememberize the odd-even identities, you know, I'm just saying, the last time I said, hey, memorize it like this, y'all decided to ignore me, and your grades reflected that fact. So, I mean, you want to ignore me again, fine, but I am going to tell you an easy way to remember odd-even identities, and that is this: cosine eats negatives. If you remember that cosine eats negatives, you can remember the odd-even identities. Okay? They go like this. The sine of negative theta equals negative sine of theta. Easy so far. No big dealio. The cosine of negative theta. Cosine eats negatives. The cosine of negative theta is cosine of theta. The tangent of negative theta is negative tangent of theta. The secant of negative theta. What is that going to be without cheating in the book, Breeze? Well, secant goes with which one of these? So
I know what it is.
Negative. It goes with cosine.
No.
it goes with cosine. Cosine eats negatives.
Oh, right, because it's
It eats the
Sorry,
negatives.
Yeah, yeah. I was,
Eats
that was
the
the negatives.
Just looks
Now
at them
goes-
and passes them up.
It eats the negatives. I was confusing it with sine. I'm sorry. Because you said it before.
I know, I did that on purpose.
Yeah. He did it on purpose. He's cheating.
Easy peasy. Let's do an example.
Let's do an example.
If the sine of x equals negative 0.37, find the cosine of x minus pi over 2.
That where are those things? That's easy. That's just
So easy.
cosine equals 0.37.
Does it?
Are we going to assume that x is negative? Because x is negative and cosine eats negatives. And
Wrong
cosine of
idea.
x minus pi over 2 is sine of x. So,
We would use
I'm
the-
pretty sure I'm right here.
Pretty sure you're right
We would
there.
use the co-function identities.
And I did, and that got us...
Okay. Things happen, and then
No, I did. And sine x equals cosine x minus pi over 2 equals negative 3.7. But cosine eats negatives.
So it's going to be
point.
this. So it's going to be this. So your logic is right up to the last part.
So it's negative 0.3.
Yes, because if it wasn't cosine, it would be the opposite of this one. So it would flip the sign. But cosine eats negatives, so it's the same as that one.
Oh.
That makes sense?
That makes sense now.
Yeah.
That makes sense now. So if it was cosine to sine, it would be positive. But
And if you want to see an example walk through of one that doesn't eat the negatives, that example 3 walks through that. And it shows like all the intermediate steps and whatever else. Okay. All right. Let's do some simplify problems. These are the first of the best. These are not my favorite. My favorite are the ones that say prove. But
Not like those. Oh, no.
These ones are more fun than the geometry ones, although, especially when you're first learning stuff, but even sometimes if you practice it a lot, you will end up filling a page and realizing, okay, this direction is not working. Let's go back up to here and try again. So, so they're fun, lots of fun. So the instructions say simplify. We're going to simplify the secant of x minus the tangent of x times the sine of x. Now, just like in geometry proofs, there are a few kind of strategies or things to be looking for. Like remember in geometry, if you have little line segments and a big line segment, you might want to think about segment addition somewhere. If you have parallel lines, you're going to be thinking about those. Same idea. You have kind of tools that you can use to manipulate these things and to make them work. One tool that is very often a way to go is to take everything and just turn it into sines and cosines. Okay? So that can be a great place to start. Let's start there on this one. It might not be where we end, might not be the best way.
Secant is 1 over the cosine of x.
That's true, it is.
minus sine of x. Wait, would it be sine of x over cosine of x? Or
It would be sine of x. I'm going to walk this all the way out. You could probably see the,
I see.
it's gonna be okay.
right? Sine x times sine x is sine squared x. Those are like bases, right? They have the same denominator, so we can combine that into one fraction. So we've got 1 minus the sine squared x over cosine of x. Now we can go further than that. We've got a sine squared x, and if we've got a sine squared x, which set of identities ought we to be thinking about? Pythagorean identities. Do we have a Pythagorean identity that might be relevant and that we could change this something to? So sine squared plus cosine squared equals 1, right? This is what I was talking about. If we take and we subtract sine squared on both sides, we have exactly this. So exactly this equals this one. Let me walk it out. Subtract sine squared theta. Subtract sine squared theta. Cosine squared theta equals 1 minus sine squared theta. Same. So we can take this and turn it into that. Now what could we do? The bottoms?
The bottoms. They're the same.
This turned into this. This is where we are right now.
Subtract exponents.
Yeah.
Yeah,
Yeah, so the bottom can go away.
That's
The bottom
cosine.
and the top can go away.
Oh, is that what you meant? That's not at all what you were saying.
That's not what I was saying, but I meant that the bottom and the top can go away because the square.
So all of this equals cosine of x.
That's great.
Very often, when you're doing one of these where it says simplify, you'll end up with like one or two trig functions at the end. Let's do another one.
That just annoys me a little bit. It also makes me happy a little bit.
That it all
Also
equals
annoys me a lot.
Interesting. Well, now we can just memorize the fact that if we ever get secant of theta minus
Yeah, that's true. This is now kind of a new identity. If you want to memorize all these, I don't do that. But you know.
Will do somehow. They'll just look at it and it'll make you mad and you just look at 100 on the test sheet and like, you don't do anything.
That's not what's happened the last couple of tests.
Yeah, the last couple of tests were memorized. Well, part of that one was. Part of that one was.
So let's do this one. Negative cosecant of pi over 2 minus x minus tangent squared x secant x. All right. The instructions say to simplify. So got a few different directions we could go. What might we to do?
Well,
Convert to
secant.
cosine of sine.
That is secant.
That is secant. That's true.
And secant is cosine.
Is it secant or is it negative secant?
It's negative secant, but
Because it's not cosine.
yeah.
Because cosine eats negatives.
But so does secant. Look at the things. Secant also eats the negatives.
But it's not negative anymore.
Well, the negative's on the outside, and this one's not negative. Yeah. I follow what you're saying. You were saying something intelligent. I thought you were talking gibberish again. Okay, what now?
And now. Oh wait, no, that's multiplying.
We can just like kill two secant x's.
Okay, so kind of. We can't kill them. They can't go away. But we definitely can do something with them that would be definitely useful.
Putting them into cosine.
Nah, we don't even need to go that route. We don't even need that tool. We could turn everything into sines and cosines. That would be a route we could go. But there's an easier one. What if we factored out a negative secant?
Then we just get negative secant.
We got
Times
negative secant times.
tangent squared.
There's 1 plus.
Oh, now what do we have?
And now we have a Pythagorean theorem, and then
We have a Pythagorean identity. That's true. What does 1 plus tangent squared x equal?
That's secant squared of.
It's equals secant squared x.
so now we get negative secant cubed.
We do.
Holy crap. This is making sense now.
It's kind of fun. Let's do another one.
Still not like calculus.
I still don't like any of it.
Well, so calculus is not hard because of the calculus. Most people that struggle with calculus, they struggle with it because of either the algebra or the trig or both that's in calculus. And so the better we're foundationed on both of those things, the better off we are. You can blame whatever you want to blame, but you know.
Trig's the father. Blame trig. I don't know. Why do you keep randomly flicking me in the middle of class?
Because it's kind of fun.
Are you wearing the boots?
Oh yeah, I am wearing the boots.
Nice boots.
They are nice boots. They look
Quite
good.
nice boots.
They also look comfortable. They are. Except last week you decided to go shoeless.
Yeah.
Shoelace.
On Tuesday.
Shoeless. You started taking your shoes off during class.
Oh.
What?
You had the flip flops on?
Yeah, I had the flip flops on.
You're taking them off.
Okay. So the instructions still say simplify.
Exactly. So you were shoeless.
What could we do?
We could
Write it down on our
Oh,
paper.
the tops are the same, but the bottoms are almost the same.
Okay, so the denominators are not the same. In order to get those two fractions to be one fraction, the denominators got to be the same. How could we make them the same?
It's just a stupid negative.
Cross multiply.
I want to just.
Well, kind of. Kind of. You're,
We
that's
have
not
an
really
eraser.
what you. It's not really what you mean.
We have an eraser.
Oh, right,
We
multiply
can
by
multiply
the
by the
freaking-
negative.
Oh, right.
Well, you're multiplying by this,
Well, yeah.
and multiplying that one times this.
Yeah, so that the bottoms are the same. And it's kind of.
There also happen to be conjugates, right? So we can go ahead and do that distributive in the bottom because the outside and inside are going to cancel, right? Since they're conjugates. So you only have to do the first and the last.
Oh, wait, it's secant squared is a Pythagorean thing.
It's almost like it's all connected.
It's all connected.
So up in the numerator over here, we have cosecant of x minus secant x cosecant x plus, this is over here now, cosecant x plus secant x cosecant x.
It sounds so funny.
In the denominator, we just have to do the first and the last, right?
And those can.
1 times 1 is 1.
Whoa.
And then secant times secant is secant squared. So plus secant squared x. And yeah, in the numerator, we chop some stuff up a little bit.
And then we combine those and kill those.
Chop those. These get combined. Cosecant x plus cosecant x is 2 cosecant x, right?
1 plus 1 is 2. But there's 3 cosecants.
Okay.
Where's the third?
All the way on the end.
Now what?
Oh, yeah. And now we have on the bottom is,
Do we?
Wait, what is it? 1 plus secant x is equal to.
you know,
No, it's not.
It's not.
It was.
and then now it's not.
No, it's not. Okay, what can we do now?
Now we.
Good question.
Give up.
Let's turn it into sines and cosines. Why not?
Sure.
Let's turn it into sines and
Lung discomfort.
Okay, now what?
Now we got to do some reciprocaling.
Not yet.
Not yet. Oh yeah, because we still have the one.
Still have the 1. Got to multiply this times cosine squared over cosine squared.
And now we do reciprocating.
Now we do reciprocaling.
Now we get 2 cosine squared x. Wait. Never mind. And we get cosine squared x plus cosine squared x sine x plus sine x. We have cosine squared in the boat. Cosine squared.
Cosines.
But it's not in the
Cosine
y.
x
It's not in the y.
Cosine x squared plus 1 is cosine.
What could we do now? Generally speaking, and sometimes you can kind of intuit, it's best to not distribute until you have to. Because sometimes stuff can happen.
Can we do something with the cosecant or?
Yeah, we could turn
cosine
the bottom
squared?
into sin x cosecant squared.
We can. What are you saying?
The same distributed bottom.
No, we're not.
That's
What are you
That's not
saying?
what we're saying.
That's not what we're saying.
What are you saying?
Cos squared plus 1 is also equal to, what is it?
No, it's not.
No, it's not.
No, it's
Can we not do it? Sine squared plus cosine squared equals 1. Wait, how do we get the 2 cosine squared of x? Reciprocal. Divide
We
that
flip
there.
this one over and multiply.
Oh, right.
Yeah. I'm not seeing so far how this is going to end up like the book says. Well, we're going to keep going. I wonder if instead of doing that, if you did the conjugate, no, because then you end with the fourth.
How did sine become cotangent?
Cosine over sine is cotangent.
Oh, the squared.
Yeah, that's why there's still a cosine here, but one of these turned into cotangent
Uh-huh.
because cosine over sine is cotangent.
But we don't know one squared. Never mind.
Can we get this all in the same trig function? Not really. How did they get there? -2 cotangent squared. Cotangent squared. Did we make a sign mistake somewhere? We did.
Where?
We totally did. I bet we can go like way back to right here. Because there was just a mistake. Yeah, y'all find the mistake. It's going from here to here.
Top and bottom.
I'm not telling.
One of them.
One of those.
Crap. That, yes. That's correct. And that is also right, so it's not on the top. Oh, did you like distribute wrong with the
Yeah.
negative square? I'm looking for it. Divided by square. So that would be
1 times 1 is in fact 1. That's
1
true.
squared.
But secant x times negative secant x
To be negative.
is negative secant squared,
Yeah. It would be different.
which is going to make a big difference. The numerator is still 2 cosecant x. What can we do with the denominator now? I'm gonna write it out because this one has got a couple of tops.
Squared.
No, it's not.
It's not. It should be.
It shouldn't be.
Oh no, negative. Wait, why is it?
Hold up.
Oh,
Wait a
one's
minute.
not negative.
If we subtract this, we end up with -1 plus secant squared x, which is exactly opposite of this, which means it equals exactly opposite of this, negative tangent squared.
Okay.
So they go one step further, which is probably good. Oftentimes, when you do a simplified one, you want your whole answer to be in the numerator. So how could we get that to be in the numerator?
Negative or to the power of -2.
No. We never want negative exponents. That's like never the right answer. We can do it without that.
We don't want eyes. Wait, no, that's not how.
That's not.
That's not how that works.
That's not how that
That's not. Yeah, I should.
Oh, because it's yeah.
You know, they're thinking way too complicated.
Well, that's always the first thing that comes into my mind is just thinking negative, Nick. You move.
It's true. Let's do another one.
Huh? Because 1 over tangent is cotangent.
Right.
And then the negative is because it's negative tangent. And it's squared because tangent is squared.
I'm gonna write that down real quick.
Okay.
What'd you say?
He's going to write that down real quick.
How quick?
Because it's going away.
Not quick enough.
Very quick.
Hurry up.
Oh, it's
Keep
going
writing.
Oh, it's
Gone.
gone.
It's
Oh,
gone.
it's gone.
Wow.
Good thing photo math exists.
Yeah.
Okay. Let's do another one.
Your book has some issues, Malcolm.
It looks like it got wet.
It got very wet.
I don't know who spilled
Like it got wet.
pound of water.
Yeah, full gallon right there.
Okay.
Got like 400 bricks on it to make it flat again.
Now what should we do?
Do we want to put everything at the top yet?
It wouldn't just put it in the top because the plus.
Oh. Yeah.
So, another strategy that you can have in your back pocket on something like this. There's definitely more than one way to solve this problem. We're probably going to have to do this strategy eventually either way, even if we were to like turn into sines and cosines and try to like flip stuff around and all that stuff. We probably would still need to do this strategy, probably. But we can just multiply by the conjugate and see what happens.
See what happens. Oh my god.
Well, that's literally like all of these problems is,
Let's do something and
and see if this maybe helps.
Malcolm, he's using a colored marker.
I thought his place was down there in the gym.
That's what you said.
Okay. In the numerator, you can distribute, or you can wait to distribute. You can leave the 4 just chilling, or you can go ahead and distribute it. I think I'm going to leave it chilling.
I like my force chilling.
Okay. Secant times secant is secant squared. Minus tangent
Because it's different
squared.
squares or whatever. It's gonna be different squares.
whatever.
So it's gonna be no middle, whatever the crap.
Because they're conjugates,
They're common.
not difference in squares, but yeah.
Yeah.
It is now a difference in
Now
squares.
it's difference
I thought you were going to suggest factoring,
No.
which is something we could do, but it would just turn it back into this. So,
Do we really want to do that?
so that probably isn't helpful. Okay, now what?
Now, we can. Secant and tangent do a Pythagorean thing.
They do a Pythagorean. That might be helpful.
There's no 1.
That's true. There isn't a 1.
Tangent squared plus 1 equals secant
That's
squared.
right, that's right.
But there's no 1. So how do we make 1?
Just you add 0.5 plus 0.5.
Dollar sign.
Money.
Money.
No, that's tangent squared.
Dollar sign.
Well, could we rearrange this somehow maybe?
Yes, 1 equals secant squared minus tangent squared. Yeah, we have that, but
Wait, so we can
Whoa!
That Where do we get the 1? Right there.
This is what I'm talking about. You just get to kill everything and make the whole one.
And so it all goes away.
We throw in a hit of death.
Very fun. Homework 1.
Does everyone
I don't know why you're still surprised. You've been in pre-cal this whole semester.
Because it's like a whole 23 problems here.
5-2, verifying identities.
Oh, wait, we're doing another.
We're going in on it. Oh, no.
I don't have another piece of notebook.
I literally don't have another piece of notebook paper.
Sad.
Well, it's got to be super short because we only have 10 minutes left. So. It shouldn't take that
We're going
long.
to jump right in with examples. The instructions say verify that.
Next time, Hooper. I'll give you an extra piece of paper next time.
Thanks.
Probably not, actually.
What about you, Reese? No, no.
Secant squared.
I hate to tell you, but I definitely will not.
Theta.
That was just a
Cotangent
little bit of
Theta.
Oh, fibulation.
minus 1 equals cotangent squared theta. So this is kind of the same, except it tells us the finish line. And so some teachers, professors will make you only work on one side of the equation, and some will allow you to work on both sides. I am the latter, not the former. You may work starting either side, you may manipulate both sides. Your goal is to make left side same as right side. That is your goal.
your mission if you choose to accept it.
What is 35 plus 32? You probably have a calculator. You got this. Okay. Anyway,
Okay.
Oh no. This guy.
that guy. Okay. So, what should we do?
We should.
Send 0.
We should smack that guy. I hope we have the exact guy from here.
We can. Wait, I actually will. We can.
I know what I would do, but I want to hear what y'all
Secant squared into tangent squared plus 1, and then the ones can't cancel. Never mind.
I'm glad you caught that before you sent me on a wild goose chase.
Would you have gone on that wild goose chase?
Yeah, that's definitely not the best way to go about this problem, but we could have gone there.
We can put. Oh, no. It's not because those are cotangent and we have tangent. And so it's all the same.
Your face has cotangent.
I'm sorry, what? Your face is cotangent. Dang it.
That's crazy.
Or do we want to change?
Okay, so we are just gonna like, okay, I thought that's what we might do, but then I was like, nah. Wait, what?
Okay, makes sense. No, it does. Oh, yes, it does. Yes, it does. And then we're going to do that to the other one, too.
Nah, leave the other one. Leave him by his lonesome. He's fine.
Oh.
I mean, you want to. If you wanted to take more effort, whatever.
I don't like more effort.
Well, no. No, because of the stupid one we can't. Never mind. Ah. And then that becomes, oh. And then that becomes cosecant. Is there a cosecant squared?
Hold on, there's a cosecant to
Oh,
cotangent.
but then it turns into that.
Cotangent squared.
Verified.
Cotangent squared.
These problems are like, just so we're clear, these problems are like Stormlight Archive, journey before destination. You can't just write cotangent squared equals cotangent squared. Done. You have to like do the stuff. Because obviously it does. That's the whole point of the problem, right?
On my test, just write cotangent squared. Cotangent squared.
Just right, verified. Done. Let's do another example.
I feel like if you wrote that on your test, I think Sean would give you negative points. He
Well,
wouldn't give you 0 points. but he would
right.
give you negative points. He'd be like, this problem you got right over here.
Okay. Let's do this one.
Gone. Didn't get that one right anymore.
God. He'd rather have you put nothing on the wrong one.
Equals equals.
It all
That's an alpha.
Oh, it wants to be though.
It wants to be. It's so close to being.
It's a wannabe infinity. I don't even know how to draw that.
It's
An
like
O and a C.
Yeah. Or you could just like start at the top and go around and go kind of like a sideways name, except you're close.
I like the OC better.
OCD.
Orange County.
You don't need to see it again. Alright. Alright.
Okay, what now?
Dirt. What's the word? What is the word? Signs on the bottom.
They're conjugates.
Yes.
They are. That's true.
Oh my word.
That's true.
So do some multiplication.
Sounds great.
Multiple multiplication.
Multiplication.
Multiple multiplication.
Multiplication. When was that like? When was that like in debate? That was never. That was never. Okay.
Y'all calm down.
Shut up. Nobody asked you. That's so long.
That's a lot of sine and cosine and happiness. It's also sadness.
And then it looks like we got some cancel.
A lot of cancel it.
Not a lot, just a little bit. And then some combinations.
Yes.
And then, oh wait, we're trying to get into secant. Oh, secant is cosine though, and we can turn the bottom into cosine squared.
We could turn the bottom into cosine squared alpha.
Now what do we do? We're trying to get to secant. And there's 2, and there's a square. And we're trying to get to the 2.
Bruh. One of them cancels with one of them?
Yeah.
Yeah.
But then it's
Cosine.
2.
Why are you looking confused? 2 secant alpha equals 2
I was
secant
doing
alpha.
the math in my head.
Which part of it?
The cancel is the canceling and then making them both secant.
Well, there's only one, because we canceled one of them. So there's only one on the bottom.
Yeah, I know.
So the only step
You
I
can go
skipped,
secant.
the only step I skipped was cosine on the bottom. And then it becomes secant.
Only step you skipped.
Only step I skipped.
Skippers.
Scabbers.
What? Skippers, scabbers,
Scabbers.
scoobers.
I don't know that I want to do this next one in 2 minutes, so we will pause right there and pick up on Tuesday.
Tuesday. On Tuesday. Tuesday? Don't even. Tuesday? Another British. British? You're not British in it? Go to England and learn some darn British.
You're not Brit-ish. Ish Brit.
I wouldn't say that I'm scared, but I am concerned.
That's a very fair concern.
Get my bottle of water.